Hello everyone, this is Kalpana here. In this video, we are going to see the method of undetermined coefficients. So we are going to discuss this topic using an example also. So let's get started. If a differential equation of the form an d power n y by dx power n plus an minus 1 d power n minus 1 y by dx power n minus 1 plus so on plus a1 dy by dx plus a naught into y equal to RHS part, which is some function of x. Okay, where an is not equal to 0 and the RHS part, which is function of x, is not equal to 0. Then the solution to this equation is given by y equal to yc plus yp. Okay, y equal to yc plus yp will be the general solution to this equation or equation of this form. Okay, and here yc is a complementary function. Yp is a particular integral. If the RHS part is 0, then yc will be the resulting general solution to the problem. Okay, we can call the RHS part as some q of x or capital X, okay, or some r of x, whatever. So we'll begin with the type 1, where yc and q of x has no common terms. Okay, if yc and q of x, if yc and q of x has no common terms, then we'll choose a yp such that yp should satisfy the given equation. Okay, we'll make a trial and choose yp here. Okay, we'll assume otherwise, we'll assume something with the help of q of x and yc. Okay, no terms of yc and q of x are common. Then we have to choose yp based on yc and q of x. We'll see that. Okay, if suppose we have q of x, that is RHS part, say some q of x equal to sin x, suppose. Okay, and yp equal to some c1 e power x plus c2 e power 2x, say, assume that. Okay, now observe yc and q of x. In yc we are having functions of x, e power x and e power 2x, right? You can call it as solution set otherwise. And in q of x we are having sin x. Do we have any common terms here? We don't have any common terms. In solution set you are having e power x, e power 2x, which comes from yc, and q of x has sin x, right? By observing these two, we can say that it doesn't has any, it does not contain any common terms. Okay, so here we'll choose yp, which contain q of x and all its linearly independent derivatives. yp will be the linear combination of q of x and all its linearly independent derivatives. So here we are having q of x equal to sin x. So yp should be q of x and all its linearly independent derivatives, right? So let's see. We have q of x equal to sin x. Okay, when you have sin x, yp should involve sin x and its derivatives. So I mean linearly independent derivatives. So derivative of sin x will be cos x, right? Already we have q of x and its derivative, right? So we'll assume yp as, take some constant, say a into sin x plus another constant b into cos x. Okay, so you need to get some finite sort of q of x and its derivatives to find yp. Okay, so repeatedly if you find derivatives of these two, again you'll get derivative of sin x minus cos x, derivative of cos x again sin x. Okay, again if you want to find derivative of cos x, you'll get minus cos x derivative sin x. If you want to find sin x derivative cos x, repeatedly you'll get sin x and cos x, right? You'll just get sin x and cos x, right? So yp will be a sin x plus b cos x, that is some constant into sin x, some constant into cos x. Okay, so we'll substitute yp in the given differential equation. We have to choose such yp, right? Such yp, I mean we have to choose a yp such that it satisfies the given differential equation, right? Now leave it like this and let's see a problem, an example problem. Solve y double dash plus 2y equal to e power x plus 2. So we are given a differential equation y double dash plus 2y equal to e power x plus 2, right? Consider some equation 1. Okay, we can also write this as d square y plus 2y equal to e power x plus 2. Now take y common from the two terms of LHS, okay, which is of f of d into y equal to some q of x form, where f of d equal to d square plus 2, right? Now the solution to this equation is given by y equal to yc plus yp. We know that because we are having RHS part also, right? So we'll begin with yc. Firstly we need to find yc. So we know that we can find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d, just replace d by m, then you'll get f of m equal to m square plus 2. Then the auxiliary equation becomes m square plus 2 equal to 0, which gives us m square equal to minus 2, then m equal to plus or minus square root of minus 2, or we can write this as square root of minus 1 into 2. We can split the square root as plus or minus square root of minus 1 into square root of 2. Since square root of minus 1 is I, you'll get plus or minus I into root 2. Okay, we know that when m equal to a plus or minus ib, yc will be e power ax into some constant c1 cos bx plus c2 sin bx, right? In case of a0, you'll get e power 0x. E power 0x is e power 0. Since e power 0 is 1, so you'll get 1 into c1 cos bx plus c2 sin bx, which is c1 cos bx plus c2 sin bx, right? Now using this, we'll write yc, that is a complementary function. Yc equal to, compare plus or minus I root 2 with plus or minus ib, then for b equal to root 2, you'll get one constant cos c1 cos root 2x or x into root 2 plus another constant into sine x into root 2. Okay. Now from this we'll get the solution set. Say s equal to cos x root 2 and sine x root 2. Also we have q of x, or the RHS part of the given differential equation, which is e power x plus 2, right? So now compare e power x 2 and this. You don't have any common terms, right? There is no common terms in q of x and c, yc otherwise. Okay. Therefore, q of x has no common terms with yc. Right. Now, using q of x, since there is no common term, q of x has no common term with yc, right? Here we are having e power x and 2. Here we are having cos x root 2, sin x root 2. There is no such common term, okay? Or there is no common term simply. Now we need to choose a yp. So for that, we have q of x. One term of q of x is e power x. Yp should involve q of x and its linearly independent derivatives. Okay. So in order to find q of x and its derivatives, I'm picking one term from q of x. Okay, I'm taking e power x. So yp contains 1 e power x plus its derivative. Its derivative will be again e power x, which gives us 2 e power x, right? So a term of yp from this e power x will be some constant into e power 2x. Okay, because you are getting again a constant into e power x, right? So you will pick a e power x from e power x, or using e power x. Again here you are having 2, which is a constant, right? You'll get plus, you should get this 2, that is q of x, and its derivative. Its derivative is 0, so you'll get 2, which is a constant, right? So we'll replace it by a constant, say some b. Take b. So you'll get plus b here. So you can easily follow the textbook. You can easily follow the formulas from textbook. Okay, it's really easy, but in some cases you'll get confusion. So how to choose yp and all. Better if you find this useful and helpful also. Okay, fine. Now we got yp. See, from e power x we got repeatedly e power x, right? So set e power x. You have finite family e power x. So you'll just pick e power x and you'll put some constant. Likewise for constant, you'll just repeatedly get constant and 0, whatever. So you'll get repeatedly constant. So instead of taking this 2, you'll take b. That's it. Okay, fine. Now coming to yp, we'll find yp dash, which gives us derivative of a e power x is a into derivative of e power x is e power x plus derivative of b, which is an unknown, right, is 0, So yp will be a e power x. Now coming to yp dash, yp double dash is equals to a into derivative of e power x is e power x. Okay, you can, if you want, you can just include one more step. Okay, right? Yp double dash is derivative of yp dash, that is derivative of a e power x. You'll get a e power x. Now we choose yp such that it should satisfy the given equation. So now we'll write equation 1 as yp double dash. Okay, now we'll write 1 as equal to e power x plus 2. Just replace y by yp simply. Okay, by 1, that is given differential equation. Now substitute yp double dash and yp in it. Consider it as some equation 2 if you want. Equation 2, not equation 2, it's equation 3, right? Already we have considered equation 2. Consider as equation 3. Now this equation 3 becomes, substitute yp double dash, which is a e power x plus 2 into yp, a e power x plus b equal to e power x plus 2, which gives us a e power x plus 2a e power x plus 2b equal to e power x plus 2, which gives us a e power x plus 2a e power x is 3a e power x plus 2b equal to e power x plus 2. Now equate the equations of like terms to find the values of unknowns. See, these unknowns are the undetermined coefficients. We call these unknowns as undetermined coefficients, so that the method is called method of undetermined coefficients. Okay, equating the equations of like terms. Firstly, we'll equate the term involving, we'll equate the equations of term involving e power x. You'll get 3a equal to 1. From this, you'll get a equal to 1 by 3. Now we have constants, right? Let's equate constants. 2b equal to 2. From this, you'll get b equal to 2 by 2, which is 1. Therefore, a equal to 1 by 3 and b equal to 1. We got a and b values. Now we'll substitute in yp, since yp equal to a e power x plus b, right? Substitute. We have yp equal to a e power x plus b. Substitute a and b values. We'll get yp equal to 1 by 3 into e power x plus b, 1. Therefore, yp equal to 1 by 3 into e power x plus 1. Right? Now, the general solution is given by y equal to yc plus yp. Let's substitute the yc and yp in it. We'll get c1 cos x root 2 plus c2 sin x root 2 plus yp. 1 by 3 e power x plus 1, which is the required solution to our problem. you want, you can just verify using yp equal to 1 by f of d into q of x. Okay, you can verify using this formula. Okay, here I have f of d equal to d square plus 2. I'm going to verify yp here. Verification. Yp equal to 1 by f of d into q of x, where f of d equal to d square plus 2, q of x is e power x plus 2. I can write this as 1 by d square plus 2 into e power x plus 2 into 1 by d square plus 2 into e power 0x. I substitute d equal to 1 here and d equal to 0 here. I'm in the second term. So I'll get 1 by 1 plus 2 into e power x plus 2 by, you need to substitute the value of quotient of x, right? You need to substitute d. This will compare it with 1 by f of d into e power ax. Then for a equal to 1, we'll substitute d equal to 1 here, and here for d equal to 0. From e power 0x, we'll substitute d equal to 0. Okay, we'll get 0 plus 2. It's 2, right? Yeah, 2 into e power 0x, which gives us e power x by 2 plus 1, 3, plus 2 into e power 0x is e power 0x is 1, which gives us e power x by 3 plus 1, or 1 by 3 into e power x plus 1. See, we got the same thing. Okay, and also we have to remember that if RHS of the equation contain tan x or secant x, the method fails. Okay, because if you have say some RHS part tan x, then we need to find its derivatives, right? What is the derivative of tan x? You will get secant square x, right? And here it is not possible to write finite set. It is not possible to write the derivatives in finite set. Okay, because the terms gets increased, we won't get end, we can say that. Okay, so we have to remember that the method of undetermined coefficients fail when you have q of x equal to tan x or secant x. Now let's see one more example. Let's solve the second problem. Y double dash plus 4y equal to 3 sin x, right? Consider as equation 1. We can write this as d square plus 4 into y equal to 3 sin x, right? Which is an operator form, say f of d into y equal to some function of x, or the RHS part you can either write it as q of x or r of x. Okay, fine. Now we have f of d equal to d square plus 4. We know that the solution to this equation is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find this using auxiliary equation, and we'll find yp using trial method, right? Now the auxiliary equation is f of m equal to 0, where f of m equal to, just replace d by m in f of d, then you'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equal to 0, which gives us m square equal to minus 4. Then m equal to plus or minus square root of minus 4. We can write it as square root of minus 4 into, minus 1 into 4. You can just split the square root. Since we know that square root of minus 1 is I, just replace square root of minus 1 by I. You will get I into square root of 4 is 2. Right? Therefore, m equal to plus or minus 2i. We know that when m equal to plus or minus ib, then yc will be some constant into cos bx plus another constant into sin bx. Yes. Now using this formula, we'll find our complementary function. Y is equal to, just compare plus or minus 2i with plus or minus ib, then for b equal to 2, you'll get c1 cos 2x plus c2 sin 2x, right? Therefore, y is equal to c1 cos 2x plus c2 sin 2x. Now we need to find yp. See, using yc, we'll write the solution set. Here, the solution set is, say S for solution set equal to, write the terms of x, cos 2x and sin 2x, and q of x is the RHS part of the given equation, 3 sin x, right? Observe these three. We don't have any common term, right? Q of x contain no common term with yc, otherwise, okay, or s, whatever. So yp must have a linear combination of q of x and all its linearly independent derivatives. Now we'll choose a yp such that it should satisfy the given equation. Okay, so for that I'll consider yp term. You have 3 sin x, right? Just neglect 3, which is a constant. Consider 3x, sin x from q of x. As I said yp should contain q of x and its derivative and its linearly independent derivative. So the derivative of sin x is cos x, right? Plus cos x, just write plus cos x. What's wrong in it? Write cos x. So here sin x and cos x, a finite set. Again, if you want, see, check it. Cos x derivative is minus sin x. Sin x derivative is cos x. Again, cos x derivative is minus sin x. Sin x derivative is cos x. You'll just repeatedly get the term sin x and cos x only, right? There is no another term from sin x, right? So you'll have finite set sin x and cos x. Okay, q of x and its derivative gives sin x plus cos x. So here we'll pick yp as yp equal to, we'll take sin x and cos x in it, right? Sin x, take one constant or some coefficient to this sin x, and cos x, a coefficient to this, say b. Okay, we'll choose yp equal to a sin x plus b cos x. Or directly, when you see sin x, and if you don't have common term in q of x and yc, then simply looking at this yc, or looking at q of x, if q of x is sin x or cos x, or you can say sin ax, say sin ax or cos ax. If q of x equal to sin ax or cos ax, then yp will be directly a sin ax plus b cos ax. This is a formula. Okay, fine. So it is difficult to remember the formula all the time, so we can just find the derivatives of q of x and pick the repeated terms, and using the repeated terms we can write yp. Okay, fine. So yp equal to a sin x plus b cos x. Now find yp dash, derivative of yp, a into derivative of sin x is cos x plus b into derivative of cos x is minus sin x. So from this you will get yp dash equal to a cos x minus b sin x. Now find yp double dash, that is derivative of yp dash is a into derivative of cos x is minus sin x minus b into derivative of sin x is cos x, which gives us minus a sin x minus b cos x. So we should choose a yp such that it satisfies the given differential equation, because yp is a particular integral, right? A part of solution, and also it satisfies the given differential equation, right? Now we can write the given equation as yp double dash plus 4yp equal to 3 sin x. We are solving the second problem, right? Fine. Now substitute yp double dash and yp in it. We have yp double dash, that is minus a sin x minus b cos x plus 4 into yp, a sin x plus b cos x equal to 3 sin x, right? Which gives us minus a sin x minus b cos x plus 4a sin x plus 4b cos x equal to 3 sin x, right? Now minus a sin x plus 4a sin x gives 3a sin x minus b cos x plus 4b cos x gives plus 3b cos x equal to the RHS part 3 sin x. Now we are going to equate the equations of like terms. We'll begin with sin x, because we have a term sin x in RHS, okay? More convenient. 3a equal to 3. From this you'll get a equal to 3 by 3, which is 1. Therefore a equal to 1. Now equate the equations of cos x. 3b equal to, we don't have any cos x term in the RHS part, so you'll get right 0. You get b equal to 0, right? Therefore a equal to 1 and b equal to 0 are the values of unknowns. Now put it in yp. We have yp equal to a sin x plus b cos x. Now substitute a equal to 1 and b equal to 0 in it, and this becomes yp equal to 1 into sin x plus 0 into cos x, which gives us sin x plus 0 sin x. Therefore yp equal to sin x, and the general solution is given by y equal to yc plus yp. We have yc and yp, substitute. You'll get y equal to c1 cos 2x plus c2 sin 2x plus yp plus sin x, which is the required solution. Now let's verify yp. We can use 1 by f of d into q of x to verify yp. Okay, we have f of d square plus 4, q of x 3 sin x, right? D can be replaced by, just compare it with 1 by f of d into sin bx. Okay, then for b equal to 1, you'll get minus 1. Just replace d square by minus 1, then you'll get 3 into 1 by minus 1 plus 4 into sin x, which gives us 3 into 1 by minus 1 plus 4 gives 3 sin x, where 3 gets cancelled, you'll get sin x. Right? You got the same thing. So therefore, is the required solution. These are the formula. Okay, it's a naught so for finding yp, we'll just try to find the derivatives of q of x. Okay, the derivatives which can be expressed in terms of finite family, and in that finite family we'll choose yp such that it satisfies the given differential equation. Fine. So we have seen two examples from the method of undetermined coefficients in this video, and also we have seen small intro part. I hope you'll understand. We'll see you in the next video. Until then, bye bye.